This is the notes for 1.1, 1.2 similarity with corresponding sides and angles. We're going to start by reviewing, though, the difference between perimeter and area. So it says perimeter, I add all of the sides together. So if I had an example that looked like this, my perimeter is how many boxes go around the outside. So I think of it like a fence. So I have 1, 2, 3, 4. And then on the other side, I have 1, 2, 3. A lot of times they may only give you that information in a picture, but I know if it's a rectangle, if this side was 4, this length should also be 4, and this length over here should also be 3. So when I go to find my perimeter, it's that fence around the outside. I add 4 plus 3 plus 4 plus 3. Altogether, that should give me 14. I also need some kind of label. I'm just going to go ahead and put 14 boxes here. In your pictures, they'll usually have inches or centimeters or some type of measurement for you. Okay. Then on our formula sheet, it says area is the base times the height. So area is how much is inside, how many boxes. So instead of having to count all of these individually, my shortcut is to do the base, which is the bottom 4, times the height, which is 3. So inside, I should have 12. And then for my label, I did a box times a box. So you'll see it a lot of times with that little squared up there. Okay, so perimeter is the fence around the outside. I add up all my lengths. Area is how much is inside. So I'm doing base times height because I'm counting up each individual one inside. There is a special case though. When you get to a triangle, my formula sheet then says 1/2 base times height. So my length here is 3. My base is 4. So just like last time, I'm going to do 4 times 3, but the difference is I do not have this full rectangle right here. I only have half of it. So in my formula sheet, it says 1/2 base times height. So 3 times 4 is 12, but half of that, I only have 6 boxes here on the inside. My label again would be something with a squared. Perimeter still works the same though. So this is the length of 3, this is the length of 4, this one is in between my boxes, so I'm just going to approximate to say 5. But if I have 3 lengths around my triangle, I should add 3 numbers together. So in this case, I would have 12 boxes. Okay, so it's up to you if you'd like to write any of those down in your notes there for comparison. The reminder is perimeter is the length around the outside, so I'm adding them all up. And then area is how much is inside, so I'm multiplying. So base times height, I would have 12 boxes. If it's a triangle though, it's half of that rectangle, so make sure after you do base times height, we either divide by 2 in our calculator, or you can show it as times by 1/2. Okay. All right, now let's get into some new vocabulary. Similarity. 2 figures are similar if their corresponding angles are equal and their corresponding sides increase by the same, and that's what we call scale factor. So over here in this picture, you'll notice that this length was 2 and it grew to 3. This length was 5 and it grew to 7. These diagonal ones are kind of hard to count in a box, but what we're going to discover as this unit goes on is that the scale factor is what I times them by. So it says in this picture, the side lengths in figure B are 1.5 times those of A. That's what we call our scale factor. Okay. The thing you need to keep in mind though is I do also have to have the same angles. So the corresponding angles mean like this bottom left angle is the same as this angle over here. This top angle is the same as this top angle over here. In order for me to say with certainty that these two are similar, I need to know that all of the angles are the same and my side lengths have all been times by the same factor. That's what we looked at the activity yesterday. So when we measured it with our protractor, our shape should have had the same degrees every time, but the lengths in my picture all got taken times 2 when my scale factor was 200% for my copier. Another important definition you need to know is corresponding. And this is the sides and the angles that have the same relative position in their figure. Okay, so when I go to determine my scale factor, I want to make sure I'm matching up the correct sides of my figure. As in, AB that side corresponds to DE. So I'm looking for the same part of my picture. The sides that correspond are the ones that match up with each other. It also says AC is the same as DF. So I know that these two have increased by the same scale factor. And then lastly, I have BC, which is this side right here, and that matches up with E to F. So when you hear your teacher say corresponding, just know it's the same side that's in the same position for my similar figures. So I'm looking for something to be multiplied by the same each time to get that new resulting length. Okay. The angles, though, should not change. So this bottom left angle of A should remain the same 90 degrees when I get down there to D. Or angle B should be the same as E, and it also says angle C should be the same as F. You'll see that in your pictures sometimes as a little swoop like this, or if there's two of them, that means those two go together, or if there's three of them, those three go together. Okay, there should be some kind of notation there that tells you these two angles are the same. So I match up the 1 with the 1, the 2 with the 2, the 3 with the 3. The last thing we're going to look at today is after I apply my scale factor. Here's my scale drawing. The image is the original one. Excuse me, the original one is right here. This is the image that results. So in my picture, if my original man is 5 feet tall, I'm going to go ahead and label him here. So this distance is 5 feet. His height should correspond to the height of the dragon. So this was my original, and this is my image, my new shape. Approximately in this picture, it looks like it's 1, 2, 3 times bigger. So if I was to his original height of 5, with a scale factor of about 3, my height of the dragon should be about 15 feet. Okay. So our big ideas for today are similar figures result from having the same shape. The angles stay the same. My side lengths can either be multiplied though and get bigger, or multiplied by a fraction and get smaller, but the angles will stay the same. And my resulting pictures should look the same, just bigger or smaller.